Hi everyone, so today we are going to look at composition of functions, and a little bit more specifically is looking at finding the domain when you do a composition of functions. So a couple things to remember is that the domain of f of g of x is going to be the combination of the domain of g of x, which is your inside function, with the domain of f of g of x, which is your composed function. So we're going to look at the inside function as well as looking at the composed function before we go ahead and simplify and before we find our domain. So here's one example. So we have f of g of x. So the first thing we want to do is let's find the domain of the inside. So the inside function is g of x. So g of x is just x plus 4. If you think about this, this is just a line, right? mx plus b. So the domain is all real numbers. You can use that little r to help you to write all real numbers. Then what we're going to do is we're going to actually do the composition. So we're going to start at the inside and we're going to put it into the outside function. So we're going to take g and plug it into f. So my f function is 1 over x. And in place of that x, I'm going to put in my g function, which was x plus 4. And my composed function is 1 over x plus 4. So the domain of this composed function, this is a rational function, so it's a fraction. So what we can't have, values we can't have in my denominator are 0. So what value would make that denominator 0? Well, that x would actually be negative 4. So I could have technically any number in for x, I just can't have negative 4 because that would make my denominator 0. So my domain is x cannot be negative 4. Now, when I find the final domain, my very final domain of this composition, I'm going to combine whatever the domain of the inside was, which was all real numbers, and the domain of my composed function, which was, again, all real numbers, but x just cannot be negative 4. So the way that I could write this is all real numbers, and then x cannot be negative 4. You could also write this in interval notation if you would like, with that u as the union. So I'm going from negative infinity all the way to negative 4. Notice you have a parenthesis. It can't be a bracket because it can't be including that negative 4. And then negative 4 all the way to positive infinity. Now, the second example in letter B, it's going to be g of f of x. So what we're going to do is we're going to say, okay, my inside function is my f of x now, which is 1 over x. So that domain for that inside function is x cannot be 0. This is a rational function, right? It's a fraction. So I'm looking for what values would make that denominator 0. Well, that's just 0. Could be anything else, just can't be 0. Now I'm going to actually do the composition. So I have my g function. I'm going to take my f function and put it into the g function. So when I do that composition, I have 1 over x. And then on the outside after that, it's plus 4. Notice that looks different than letter A, right? That plus 4 is at the end. So that composed function of 1 over x and then plus 4, that domain is going to be, again, x cannot be 0. So notice that it's the same domain, so I know I have all real numbers. X just can't be 0. So again, you could write this in interval notation if you'd like, right? 0 just can't have the bracket. It needs to have the parenthesis with the little union in between. Now here we have example 2. Now we're looking at f of x being x squared minus 1, g of x as 2 over x. So again, we want to find the composition and then the domain. So my inside function is f of x, right? Notice that is actually a quadratic function, right? It's x squared, right? So you think about a parabola, and the parabolas always have a domain of all real numbers. Now let's go ahead and do the composition, and f is going to go into g. So here's my g function, 2 over x. F is going to be placed into replacing that x. So I have 2 over x squared minus 1. Again, kind of notice that when I want to find the domain of that composed function, so the red, again, I'm thinking I have a rational function. It's a fraction. So I know that whatever is in the denominator, that expression can't be 0. So I'm going to set that expression and say it's not equal to 0, and I'm going to solve by moving over and adding that 1. To take the square root, I get that x cannot be plus or minus 1. So my domain is that x just can't be positive 1 or negative 1. Now my final domain is going to be the combination of the all real numbers, and then x cannot be negative 1 and positive 1. Now when we're writing this in interval notation, it's going to be slightly different than the ones if you see in the past, right? I've got the negative infinity to positive 1. And then I have that little area that's going even 0, let's say, is between negative 1 and positive 1. You could technically have 0 in there. It's going to get you a negative 1 in the denominator. And then I've got the 1 to positive infinity. So I've got like 3 little sections in my interval notation. All right, in letter B, we're going to actually do g of x. So my inside function is going to be g of x, so that's 2 over x. That domain is again going to be x cannot be 0. Anything else, it just can't be 0. Let's do that composition. So I'm going to take that g, and I'm going to plug g in again. So I've got 2 over x. Now remember, when I'm dividing that fraction, I'm actually multiplying by its reciprocal, which in this case, my 2's are going to cancel, and I'm going to get x. So x, right, is just a line, right? If you think about y equals x, that domain is going to be all real numbers. So now combining those two, I've got all real numbers, and then x cannot be 0. Again, interval notation, if you'd like to write an interval notation, we got negative infinity to 0, union, and then 0 to positive infinity. And example number 3, we are going to be looking at a radical function. We got square root of x, right? And we also have a linear function, that's x plus 3. All right, so let's look at the domain of the inside. That inside is x plus 3. That is again going to be a linear function, right? Think about mx plus b. This is all real numbers. Now I'm going to actually go ahead and do the composition. So I'm going to take that g function and plug it into my f function. So my f function is the square root of x. And in place of that x, I'm going to plug in my g function. So I have the square root of x plus 3. Now this is a radical function, right? If you think about square roots, the only number that we can't have underneath a square root is actually going to be any negative number, right? You could have 0, you could have any positive number, you could have fractions even. You just can't have negative numbers. We can't take the square root of a negative number and get a real answer. So what you're thinking about is, I'm going to take that radicand, so that's the expression underneath the radical, and I'm going to actually set it greater than or equal to 0. Now, why do I do it greater than or equal to 0? Because that expression, it could equal 0, because the square root of 0 is just 0. And it could be greater than 0, right? Those are my positive answers. So that's why I'm going to put in that greater than or equal to. So when I solve this, I get x is greater than or equal to negative 3. Now, as that domain of my composed function is x is greater than or equal to negative 3, I've got all these numbers greater than negative 3. So I can have all real numbers, and then x is greater than or equal to negative 3. So that is also included with that bracket when I've got that negative 3 in interval notation. Now, last example here with b, you've got g of f of x. So again, my inside function is the f function, which is the square root of x. That domain is going to be x is greater than or equal to 0. I'm going to actually go ahead and do that composition now. So I've got my f function going into my g function. So I've got my g function, which is x plus 3. In place of that x, I'm going to put in the square root of x. So I'm going to have that composed function being the square root of x, and then notice that the plus 3 is actually at the end, right? It's not underneath the radical like example A. It's actually on the outside. Now the domain is going to be x is greater than or equal to 0. I don't have an expression underneath that radical. Now when I combine together my domains, the same domain is actually going to be x is greater than or equal to 0. And again, writing in an interval notation, which you can, notice that the 0 is going to be included. So it's got that bracket around the 0 going to positive infinity. Now, here are some things for you to remember. Whenever you are finding the domain of a composition of functions, it's always a combination of the domain of the inside and then whatever the domain is of your composed function. So make sure you're combining those two together. And then thinking about rational functions and radical functions for its domain. For rationals, notice that my denominator cannot equal 0, so I'm finding whatever these values are that would make that denominator 0. And then for radical functions, or square root functions, whatever that radicand is, which is the expression underneath the square root sign, that has to be greater than or equal to 0 because we can't have negative numbers underneath the radical. Now, I hope you found this video helpful and are able to find the domain of composition of functions a lot better. Thanks for watching and have a great day.